Hello friends, welcome back to the bench. Our patient today is Z390 from Gigabyte. This is a very nice one with a nice I/O. We got 4 USB ports over here, 6 over here. We have optical digital audio output, which is awesome. USB-C. This is pretty much the board that I'm using in my rig that is recording right now, although that one is Asus, but it's pretty much the same thing. And now what's wrong with this one? This is kind of tricky because the socket is completely obliterated, so I can't test the CPU on it. There's, I don't know, some kind of glue or something. I don't know. It looks like someone just treated this with the hammer. Which means I can't really give it a test before I replace the CPU socket. Now, I have another one over here, which is Asus Prime Z390P, but it also has a busted CPU socket, but this one, I actually looked around and there are 3 pins missing, but one is ground and 2 of them are V-core. So technically, if I put the CPU on, I can test the board. Obviously, it's not going to perform properly, but I will definitely be able to get into BIOS and even load into the system. It just at higher load, it will likely not work because of like 2 pins missing on the V-core and 1 pin missing on ground. It doesn't seem like a lot, but you know, there's a reason for every pin over there. But this one, at least I can test before replacing the CPU socket. But I'm not going to be replacing CPU socket on it because the outputs over here, you can see we have 2 PS ports, so it's pretty old. No digital output, USB probably 2.0 at best, these two most likely, hard to say. So not enough. Well, it does have DisplayPort, which is kind of cool, but not enough outputs. This is likely not the board I will use, but this one is a low-hanging fruit because I can test the CPU on it. This one, on the other hand, this is the board that I do want to fix, but I cannot test before replacing the socket, which means if I replace the socket and the board still doesn't work, then either I messed up the replacement, which is possible, it's not that easy to do, or the board was faulty to begin with, and perhaps that's why it has been damaged here, to make it appear that it's a simple replacement. Because this is kind of I usually, when I buy these boards, I buy them with busted CPU sockets, because then at least I know what's wrong with it, right? But you never know. Maybe the SIO will be faulty, and same thing. I am building a nice collection of broken boards, so soon enough I will have the replacement parts, meaning the working SIO to replace, the set of transistors, and obviously some ports and stuff. The busted port also would have been the busted PCI Express slot also would have been a nice repair, because it's also, you know what to fix. It's only a matter of your skill to be able to replace the slots. And the rig I'm using right now, you can watch it, but what was it, about a year ago, maybe a little less than a year ago, I fixed the bent pins, because it only had bent pins, and replaced the PCI Express slot. And the board is working until today. This is ever since I built that rig, This is my primary rig that I use for recording and video editing and thumbnail and pretty much everything. So it did work. However, lately it is giving me some issues, slight issues. So that's what I'm doing here. I'm trying to build another rig to have the replacement. And the reason I don't want to just start messing with this rig is because it works well enough. Right? I don't want to, it's like engineering or technician's mantra. If it ain't broke, you don't fix it. So I need to have a backup, basically. So what I'm doing is I'm trying to build a whole new rig and just replace this one, or just have the redundancy. So in case this one breaks, I can just switch over to the second rig and life goes on. If on the other hand I have nothing to fall back on, then the rig breaks and the channel is dead for 2 weeks because I'm waiting for parts and that kind of stuff, right? So that's the general idea. So as you can see, I repurposed my microscope stand to hold the header, and we have a preheater. Still, even with that, that's not quite enough. I've done it on this one, this tiny board. So this one is a lot smaller, right? And I can't show it to you under the scope for obvious reasons, but you should see enough here. So there was one pad that I ripped, which was not connected. That's why it flew off. And I melted a little bit of the actual socket here, which means it was tough to clean. Once that melts and it burns into the board, it's really difficult to clean. And you're not going to be able to see it probably, but there's very slight warping. So I overheated it. And the reason I overheated it is because with the maximum temperature on the preheater and started with 380 up to 450, it would just reach the temperature of about 210 degrees according to my thermal imager. That's not enough to melt this. So I had to start blasting with full 500 degrees and full blast, 120 liters. And that caused the plastic to melt. So now, because I was doing the handheld hot air blowing, and now I'm gonna use this to continuously blow. I will likely do something with the aluminum foil because I don't have the big nozzle like that to just kind of limit it just to the socket, because that's what you should do, but I don't have it. So I'll figure something out over there, and I'm gonna use the second hot air station to blow manually, and that will hopefully give me enough temperature so I don't have to so I don't have to use higher temperature, basically. So at the bottom I'm gonna use the maximum heat. I will probably limit the area with the aluminum foil just to not heat up too much of the board, but it's not a big deal. With this preheater, the maximum temperature that the board can reach is about 110, 120. So the rest needs to be done with hot air blowing from the top. But the main purpose is to use lower temperature. So I don't want to blow with 500, not even 450. I would like to blow with 380. That's usually the temperature I use, and that is that is more than enough to melt the solder. It just needs to be heated uniformly, and so now you gotta keep that temperature because it's gonna start cooling down very quickly. You keep the hot air on. As soon as you remove it, it drops like that. So it's important to just kind of keep that temperature in. It's not easy. It takes a lot of time and a lot of effort, and a lot of stuff can go wrong. Like the issue that I've seen the most on while performing this is when you try to lift the socket, you just kind of mess with these capacitors inside, right? And if you just move them all, then it's kind of a pain to replace them. I mean, a pain. Once you move them, then to replace them properly and reliably, you need to remove the old solder and put the new solder on, and obviously use flux and everything. And there's quite a few of these inside on every board. So we're working on this one, and this one has, like all of them, the majority of these cups are on V-Core, some on GT, some on IO. Alright, so this is what we're gonna do. So let's see if we can do it properly, or at all. Alright, so here we have it. So, I dropped the socket, like 3 times while removing it. Surprisingly, no damage to the caps. So one over here, this one, has been slightly moved, but that's pretty much the only damage to it. But it sits properly, meaning it will still work. Obviously, I will correct it. I'm not sure before or after replacing the socket. Now, as you could see on the thermal image, the preheater only gets us up to about 115, 118. Then the hot air got us up to, and I thought that only went up to 210 or 220, but it turns out the settings on my thermal camera are the settings I was using, which I normally use to just look for the heat spots. It's on the low or mid temperatures, so up to 210 degrees. It just doesn't go higher, and that's why I thought I just can't go higher than 210. So once I switched to the high range, we went up to like 270, 280, even more than that, and that is perfectly enough to desolder it. I used flax, which I normally don't use, but I figured it's going to be easier with flax. I'm not sure if it was. It was definitely more smoky. That's why I don't use flax for desoldering. I don't think it's necessary. For resoldering, sure. But for desoldering, if you can get the temperature high enough and even, you shouldn't need flax. The solder will flow. There's no warping on the board, so we didn't overheat it. I used 400 degrees on the hot air on both stations, and I think I probably didn't need the second hot air station, because I used a little shield like this, and on the other side, so it went up in temperature pretty neatly. As you can see, I didn't remove anything from the board. I even left the plastic parts over here. I just covered it with aluminum foil, and I'm not removing it yet because I'm gonna need it to resolder the new socket. It is not perfectly clean because I didn't use the lead-free solder to put on it. Without putting the lead-free solder, without putting the leaded solder on it to mix it with the lead-free that is on here, it's very hard to clean it. But the important part is that no pads are missing, no ripped pads, no missing capacitors, and no warping on the board. So this is pretty much what we want to see after the removal. It looks pretty good. Now, after I removed it, I thought I ripped like 4, maybe 5 pads, because that's what it looked like, but I didn't have the scope, so I couldn't confirm. So I just cleaned it as well as I could without the leaded solder, and then looked at it through the optics, and it turned out that these were not ripped pads, they were corroded pads. So perhaps this board came to me or was sold as broken before, or it was deemed as malfunctioning before the damage to the socket. The damage to the socket could have came afterwards, because the board was just tossed as broken one, and it was stacked on other boards and stuff and just moved around, and that's what caused the damage to the socket. But the original fault perhaps was the corroded pads under the CPU. I actually haven't seen that yet, and this is the first one that I see with corroded pads. So under the optics, I just started soldering on it to confirm whether the pad was there, and the pad indeed was there. So now as you can see, all the pads are shiny, so all of them have solder on it. And before I spotted like 4, maybe 5 that I thought were ripped from the board, and they were just corroded. So perhaps that was the issue with the board, but we'll see once I replace the socket. Now, final thing that I found, it turns out this camera, can you see this? No autofocus. This camera does have manual focus, which I didn't know. And for a year, even more than a year, I've been using that camera, and I've been hearing complaints from you guys that the camera just keeps catching focus and it's very distracting, and I absolutely agree. I hated that, but I figured, well, I can't afford the good camera with the knob on it to set the focus and stuff. And I didn't know that all this time I had a camera that has manual focus. Well, we learn every day, or at least I do. Maybe not every day, but at least every week I learn something new. That's what I love about this business. Okay, so now what we need to do is put the leaded solder on the board, mix it with the lead-free that we have right now, and clean it. After that, we just need to put the new socket on, resolder it, and test it, and we'll see if that works. Alrighty, the attempt number 1 didn't work, but it didn't work mainly because is this the one? Yeah, I kind of melted the socket a little bit here, which could have caused the pins to deform, because the plastic would deform, and the whole socket could have deformed, causing some pins to be not soldered on. So I attempted that the second time, but after I removed the socket, again I noticed corroded pins. So I cleaned them again, soldered on another socket, same issue. I mean, the board turns on, but it doesn't detect the CPU. So at this point, I'm not sure actually, but I've never seen such an issue that the corroded pins just keep coming back, right? And I used the most aggressive flux I have, cleaned the pins, and before soldering it looked fine, but no, actually even after cleaning, yeah, it seems like what I suspect is especially one of the pins is a little lower. I believe that the layer that is supposed to be a conductive layer just flew off, just detached, because this is exposed to a lot of heat, obviously, right? And I believe the socket was just overheated, because this board supports i9s, very high frequency, a lot of temperature dissipating on this component, so it makes sense. So at this point, I think that it's either the board pods, some of the pods are damaged, and that's why it doesn't want to solder on, or there's another issue with the board that prevents it from seeing CPU. And as I said, perhaps that was the issue, and the board was just tossed onto the pile, and that's when the socket damage was done. So this is kind of a risk you always run with getting the boards that are obviously have damaged sockets, with a hope that if you replace the socket, it'll work. It's a little more success with the PCI Express ports or slots, or at least in my experience. I have a lot more success replacing the sockets or the slots, the PCI Express slots, rather than the CPU sockets. So this one, well, sorry, I thought I would have a nice ending to this video with working board. That's why I attempted the second replacement, and that's when I noticed those pins again. So I think this will be no-go. I also, with the second try, I improved my process slightly. I made sure, because in the first attempt, I just left it be. I let the gravity do its thing, right? Heat it up and rely on the gravity to pull the chip. This time I was tapping on it. I even pushed it a little to make sure it's floating nicely. So I'm positive that my procedure was done correctly, right? I monitored the temperature. I definitely got it hot enough, and everything seemed fine during the procedure. But I tested multiple CPUs just to be sure, but no luck, no go. The CPU is not detected. So I think this board is gonna be for parts, which is too bad, because I love these boards, right? Crap load of IOs and support for really powerful CPUs should I need one. So that's too bad. Well, You can't win them all, as they say, and recently I don't have much luck with these boards. But I have two more sockets. No, I'm not gonna waste any more sockets on this board. But two more, I need to order some more, and they always come from China. No one in the US sells them, and I only have one that is perfect, and one that is not perfect. Some of the pins over here are slightly offset, and that was probably during the procedure of rebolling or applying solder. Well, it just didn't work perfectly, right? You can't win them all. But when you order these, yeah, you can expect that some of them will not be, full quality, which is in this case. But I have two more, and I have one more board on which I'll just replace the socket just for the fun of it, because I want to fix at least one of these with the damaged socket. But this one, unfortunately, goes for parts, unless I figure something out. We'll see. But I'm pretty sure it's the corroded pins that just refuse to accept solder. That would be my diagnosis for this one. Well, what are you gonna do? Sorry guys, no happy ending to this one. But I hope you found this entertaining, and maybe you get a little bit of knowledge from it. If so, leave a like, and thank you very much for watching. I'll see you guys in the next one.